This is Tiaki, a diagnostic piece of wearable tech designed to improve the detection of concussion. A 3-axis accelerometer and gyroscope are embedded into the cap. These measure the linear and rotational acceleration that a player will experience during a collision. This information is then relayed to a physio on a smart device. When these forces exceed a preset threshold, a warning message will be sent to the physio, and LEDs at the back of the scrum cap will be illuminated to inform officials and players alike that the player needs attention. The detection system also takes into account the effect of secondary impact syndrome, or SIS. This is when a player experiences several high-level collisions in a short space of time, which could worsen the effect of concussion. Any collisions over 95 G will immediately set off the warning system, but once several impacts between 65 and 95 are experienced, the physio will get another warning message recommending the player should be tested for concussion symptoms at the next available moment. As well as the increased player safety aspects of Tiaki, it has revolutionised the design of the scrum cap. Listening to players who complained about the constrictive and uncomfortable nature of existing headwear, a knitted cotton polyamide elastane blend material was used. The material supplies a precision fit for performance whilst integrating exceptional breathability, surprising levels of support, and adapting to the shape of the head. Tiaki is tackling the issue of concussion head-on while supplying an unrivaled level of comfort for the player. The cotton polyamide elastane blend material will form the scrum cap base. A knitting process will be used to form a 2D net of the scrum cap shape. The process is relatively simple. It involves passing strands or strips of material under and over each other to form an intertwined structure. Fibre strength and alignment can be adjusted specifically for each application, reducing weight and material consumption. The fibre strength will be improved around the hem by increasing the concentration of the weave. This will consequently improve the tightness around the edge of the scrum cap, much like a cuff of a sock. To manufacture the 2D net at a high productivity, computerized flat knitting machine will be used. The machine has a working width of 50 by 127 centimeters, being able to knit complex patterns of differing densities extremely quickly, thus reducing the time taken to manufacture the net. This allows for a high volume production of the scrum caps and is the most simple and low-cost way of manufacturing the complex 2D shape. With differing levels of thickness throughout the design of the net, the machine works much like a 3D printer, with the yarn blend is loaded onto the looms above the machine. The thread is then put through a feed wheel, which keeps the individual strands under tension, and then is put through the combined knitting transfer system. The pattern is then knitted at high speed, and the final 2D net is fed out of the machine via rollers. This high-powered machine allows for low labour-intensive knitting process and produces the whole scrum cap base in one swift process. An additional environmental sustainable benefit is that it reduces waste because the one-piece upper does not use multiple materials, and material cuts used in traditional manufacture. This leaves no wastage material. It is truly a minimalist design with maximum return, and by far the most suitable way of manufacturing this complex part.